any country for that matter, to get to net zero emissions. Making our buildings greener and more efficient is going to be a huge, huge part of that challenge. But the first thing we need to do before we even think about whether to put solar panels on our roof or heat pumps in our kitchens is to find out where the problem is. How do we know how much heat our homes and offices and schools and churches and landmarks like the one behind me, the Royal Observatory in Greenwich, are losing? How do we know what to do first, which problem to tackle? I'm here today to have a look at a new invention that helps to solve just that problem by pinpointing exactly where the problems are with our buildings and how to fix them. Hello, Assam.
Hi, Maddie. Nice to see you.
Thanks very much for coming down.
My pleasure, my pleasure.
So this is the car, this is the BESS.
And this is BESS, yes. The Built Environment Scanning System, that's our name for the technology. Enables us to scan huge swathes of the country in the shortest time possible to try and understand the built environment in a better context of where it is and what needs doing to it as it gets to net zero. It is a Tesla.
Yes.
And that suits our purpose because it holds basically our camera system and our scanning system in the back on a robotic column that comes out the back of the boot. And in that is the technology at play. So you'll hear some fans going, and that's obviously to keep on a hot day today the technology cool and functioning the way we want. We've got LiDAR technology, thermal imaging technology and visual camera systems.
So all those scanners are in this bit here?
All in the top.
Okay.
And supporting the thing that does all of the sensing is obviously some batteries to keep it powered.
Yep.
And servers to handle the volume of data that we capture. We'll give you a laptop to sit in front of, and we'll go for a drive and you'll get to see all the technology in action. Great,
well let's go put it to the test. So what I can see here is we're just outside the Queen's House in Greenwich, which was built in 1630, so this is a very old classical building. What can we see on the screen? What's it telling us about?
Yeah, so today's quite a sunny day, and what we're seeing already is different temperature profiles on the left, as you can see. So different materials and different colours of materials are going to retain heat in different ways.
So the stone here that we can see that it's made of, that's looking purpley. Does that mean it's cool?
That's cooler.
So actually this building is staying quite cool?
It seems so, yeah.
Far?
From today, yes, it seems like it's reflecting more of the heat than some of the materials around it are absorbing more of that heat and retaining that heat.
Really interesting to see how a historical piece of architecture is performing in a summer's day. But maybe we should go and have a look and see how everyday homes and offices around Greenwich are also performing, see how they're coping with the heat.
Sounds brilliant.
We're going to go and see a selection of different types of buildings and different types of housing so that we can have a look and see what the variation is between all of them, how they're all performing on this hot summer's day, what we might be able to figure out about how they lose heat in the winter time. You can see on this block of flats next to us, the very top of it looks a lot hotter than the lower levels, which I imagine is because the sun has been beating down on the top of that roof for the last few hours.
Common area you've got there is clad in metal compared to some of the brick, and you'll start seeing all the different responses of those temperatures as you go past. Some of those surfaces holding on to a lot more heat than you'd expect.
And the cars particularly, you can really see the cars pop out. So this is interesting because we've got kind of old terraces on our right and then blocks of houses on our left. What do we know about the performance of kind of apartment blocks versus houses from what you've scanned so far?
Whether they're tower blocks or mid-rise or low-rise, you tend to see a lot of different heat loss. So some of that will be airborne heat loss, where you've got hot air from the internal space leaking out through cracks and gaps. And then you'll also have, particularly on medium to high-rise buildings, elements where you can see insulation is either slumped or been missing or incorrectly installed. So you get a localised gap of insulation, and that's normally where you'd expect to see quite a lot of things like mould growth or condensation on those surfaces because they're cooler than the rest.
And you'd see that more in blocks of apartments, for example, rather than single houses?
It happens a lot in houses. It's easier to detect on one property with multiple dwellings because you can see different heat characterisation happening across one building essentially, so it becomes easier to understand in winter.
So as we're coming past these blocks of flats here, the cladding is glowing bright orange compared to purple for the rest of it. So I think that's where they've got white cladding versus bricks. Now we're entering the Greenwich Peninsula. So we've got the Millennium Dome over there. You can just see that poking out on the screen.
They should be interesting on the left. Yeah.
You know, these should be the best of the best in terms of performance, you'd hope. So tell me what has piqued your interest.
Already see bits of cladding and works missing. You can see the metal cladding on the balconies.
Yeah.
Glowing quite hot. It's unnaturally hot actually.
Yes.
And then we've got quite a lot of glazing, which is also responding in different ways. And I suspect these are brick slip systems because you can kind of tell as you drive past them. They seem to be losing heat as quickly as they're gaining. So it looks like they're quite responsive in terms of their thermal response.
But this kind of new build development like this, Assam, given what we've seen so far and what the BESS has seen, you will have driven around lots of estates like this. Are we building the best quality homes that we could be?
No, is the simple answer. We see a lot of defects on new build construction. One of the properties on the right hand side is now missing some insulation in comparison to the rest of the properties. But when you look at enough of this data, as we tend to do, you realise that new build properties may not be built to the current standard that we'd be expecting them to be built to.
Right.
And we tend to find that cladding systems or complex cladding systems tend to have more observable defects as you collect that data. Probably not doing the construction sector as a whole a huge amount of justice in that, but those are evident bits you can see from the data as you start observing it at scale.
And that's the point, right, of this data set, is that it's going to make it easy for organisations that own multiple buildings. So this isn't necessarily for a homeowner that wants to put PV on their roof. This is for councils or housing associations that own big blocks of properties.
Yeah, for today, I think that is the big challenge across that sort of social housing, sort of owned tenure type of stock. As we go forward, there may be things that are more consumer facing, but the data set is equally applicable to an individual building as it is to a collection of buildings. By driving BESS around and evaluating the stock, we can create that common starting point. But more importantly, we also think at a minimum we'll be able to save £400 to £500 per property by just having that data early upstream as possible.
Right.
As a nation, we need to get to net zero. We've got some targets that we need to meet, and those targets are coming towards us. We have 28 million or so things in the UK that we need to understand how to decarbonise as we get to net zero. And at the moment, we have quite laborious ways in the way that we assess those buildings. BESS, the Built Environment Scanning System, was designed from the ground up to tackle those problems and issues and productivity gap issues head on, and it captures data for the built environment, and that includes a number of different technologies that come together that enable us to better understand what measures to apply to what building in what order to get us to net zero quicker.
So I've been for a ride in the BESS. I've got to see the technology in action. It's been fascinating to see how different properties, from churches to terraced houses, are performing in the heat of this hot summer's day. I also got a sense of how the data that is gathered by this car will help us understand how heat is lost during the winter months and what we need to do to help get these properties to net zero. So hopefully it's the data gathered through machines like this that can make the process of retrofitting and making our buildings fit for the future an easier, faster and more efficient process.